Okay, folks, here comes our next question. It's the AP 2017, number 4. I'll show you what the problem looks like so you can find it in your packet. And the first thing I'll let you know what this problem is, even if you don't understand all the details I'm working on, the whole thing is they really want you to understand symbols, to jump back and forth from one symbol to another and back and forth, meaning the following. I'm going to write this off to the side for a second. If they were to give you a rate of something, like, and this is not part of the problem, but I'll cross it, like a dm/dt, you need to know that that symbol also means m prime, that the integral of that, of dm/dt, would be m, and you need to move from different information just based on knowing what things are rates, what things are slopes, and what things are quantities. And we're going to go over that in this problem. Also, this would be a calculator problem at this point, so it wouldn't be as algebraic as some of the things that are listed here. So I moved the problem off the page only because it's got a lot of words in there. I'm going to break it down for you. At time 0, they give you a potato that comes out of a boiled pot. At time 0, the temperature of that potato is 91 degrees. And the temperature of the potato, as time goes by, obviously drops. It gets lower and lower, does not go below 27 degrees because that is room temperature. Now, I can hear Lucas right now saying, how can room temperature be 27 degrees? They're measuring all this in Celsius, so those particular numbers don't work in our head always, but it's fine. That's what it's going to be. So then the question says the internal temperature is modeled by the function h. So that's kind of the trick. They tell us that the temperature is based on h. I'll show you right here. But they don't actually give me an equation for h. Let's go focus. Oh, you have it in front of you anyway. They give me the function h, and then they give me an equation, a differential equation, which just means an equation of a derivative of, and I wrote that here so it's clearer. Focus. Which says dh dt equals negative 1/4 h minus 27. So here's what they've given me. They've told me I have a function h, which is temperature. I don't know the equation for temperature based on time, but I know the relationship between the rate of change of temperature is actually proportional to the change in temperature as time goes by. And then again, they tell me that h of 0 equals 91. I already knew that because I knew at time 0, the potato is 91 degrees, but they're giving me that one piece of info about the function h. So I'm going to read part A. I'll bring it over here for a second if you can't see it on your packet. It just says, write an equation for the line tangent to the graph of h at t equals 0. Once I heard line tangent, I'm not even reading anything else. Where do they want the line tangent to? At t equals 0. When you hear tangent line, forget everything else. It's going to be L equals f prime of c, x minus c, and forget u, f of c. You just need to know what your c is, and then we're probably going to have to move through different types of quantities as we go there. So they told me they want this graph at t equals 0. So that means my equation for my line, my L, I always use L. They don't always use L, but that's okay. L is going to be f prime of 0, x minus 0, and f of 0. Now I know I have the letters f in there. The question is, what function do they want me to find that at? Well, they want me to put this tangent line to this function up here, to the h function. So let's see what things are really easy to figure out. There usually are some that are easy. L equals x minus 0 is just x. I'm going to put that down. Plus, what is the value of the function at 0? The value of the function at 0 they gave me was 91. So that becomes a 91. And I need the slope at 0. The slope at 0 would be put into here to get the answer back. So I put in 0 minus 27 times negative 1/4 is going to be positive 27 over 4. X plus 91. I was going to record my mistake, record it and take my mistake out, but I think I'd rather show you the mistake I made. I didn't do anything wrong in the statement about tangent line. I wrote that down right. I wrote this down right here, but I made a mistake here on the slope. Let me show you what I did. I'll write the correct answer in red. Remember that my f is really my function h from before. Why did I write down f? Because that's always going to be the function that's there. I'm going to write h. Nope, I'm going to leave it. I'll write h. H prime. So here's the mistake I made. So this part is correct, x minus 0. What needs to go into this piece right here is the temperature at time 0. What do we know the temperature at time 0 was? At time 0, the temperature was 91, so that's right. And then here I needed the slope at time 0. So I made a mistake. I took that 0 and filled it into the derivative equation, and I filled that 0 on in. But the derivative is not based on time, it's based on heat. Well, what I needed to do was I needed to find the heat at time 0, which is 91. Put 91 into that equation. So H prime of 0 would be equal to negative 1/4 times 91 minus 27. If I put that in the calculator, I end up with negative 16 as my answer. I get negative 16 as my answer. That's my equation there. If you use this number and got this number wrong, as long as you did the other parts correctly, you'd get full credit for the problem. They asked me to use this to approximate the temperature at time t equals 3. So here we go, H at 3 is approximately negative 16 times 3 plus 91. If I put that in the calculator, did it sound like I used the calculator? I thought I did a good job on that. Temperature would be 43 degrees. And once again, I made a mistake in there. That's okay. If I made that mistake but still got an answer based on what's there, this part was worth 3 things, I would have gotten 2 points on the problem. So not really losing that much credit for what's going on. The next thing asked me to do is use d squared h over dt squared, which is the second derivative, to tell me about underestimating or overestimating at t equals 3. Okay, so basically they're going to get me 3 pieces of information. I'm going to write that off to the side in green. I'm probably going to find h at time 3, which I already did. That was 43 degrees. And I'm going to find d squared h over dt squared at 3. And basically I'm going to look for a positive or negative to see if the graph is underestimating or overestimating. So here's what I need to do. I'm going to take the derivative of dh dt to get d squared h over dt squared. So I'll take the derivative of this statement right here, which is going to be d squared h over dt squared equals. So the derivative of this would be negative 1/4. And the derivative of h is just dh dt. So that's my answer for that piece right there. Now I need to find, it's a lot of work, I know. I need to find, in order to find d squared h dt at t equals 3, I need to put t into these equations right here. My only problem is h of t is not determined by t, is determined by h. So I see a lot of parts going on. So I'm going to write this down, d squared h over dt squared at t equals 3 equals negative 1/4. So I'm going to use my time at 3. At 3, h is approximately 43. And I'll fill that into this part of the equation right here. Negative 1/4 times negative 1/4 of 43 minus 27. And I know what you're thinking. Do I need to find that number out? I don't really need to find that number, and I'll show you why. As soon as they ask me about overestimate, underestimate, all I care is about graphs increasing or decreasing, and then whether they're concave up or concave down. We know that h, based on time, is a decreasing function. We know the temperature of the thing is coming down. The question is it concave up or concave down? Here's what I'm going to do. I know 43 minus 27 is positive. I know a positive times a negative is a negative. And I know a negative times a negative is a positive. So I know this answer is positive. So I know the graph is concave up. So I know the graph looks like this right here over all the intervals. It means my tangent line, just going to graph there, is going to be an underestimate because the tangent line is below the actual graph. And in terms of words you need to write down, all the stuff I wrote down is enough right there. to get that part right. Okay, the last part says for t is less than 10, the function satisfies a different differential equation. And I've listed that differential equation right here. They've given me the initial condition, and they asked me to find g of t, so they asked me to solve this differential equation, which is going to be separate, integrate, solve, based on the initial temperature. What is the internal temperature at potato time t equals 3? So we're going to end up doing the same thing. We're going to solve this one. We're going to find the specific answer, and then we're going to put 3 in and see what we get. Now, we're going to have our calculator for this part, but I'm going to do this one without, just so you can see what is going to happen right here. So I'm going to write this how they wanted you to do it, then we'll show you how we'll do it if we get it on the test. I know I'm on a time limit because I only have 4 minutes left of the recording. I'm going to pause it for a second. Okay, here we go. I took the original differential equation, put it over a fraction, and I cross-multiplied. And I got dg equals negative this whole thing, dt. Problem is I want this over with the g. It was to a positive 2/3 power on this side, so I moved it to the other side and put it to a negative 2/3 power. Now I have the g's and dg's on one side. I have the dt's on the other side, so I've done my separating. I can now integrate. I'm going to work sideways on this for a minute. So if I integrate this statement, I know the inside's going to stay, negative 27. It's going to go up 1 unit. It's going to go to the 1/3 power. And the flip of that number goes out front, as it always does. 3 over 1. I'm going to pause it for a second. So I just simplified that little fraction of a flip right there. Right now I have enough information to find what C is, because they give me that when T is 0, G is 91. So I could fill this on in. Minus 3, 91, minus 27 to the 1/3 equals C, because T is equal to 0. So I'm going to do that in my calculator. Hold on one second. Now remember, this was originally a non-calculator question, so they probably made it easy. 91 minus 27 is 64 to the 1/3 equals C. Well, 64 to the 1/3, what times itself equals 64. 4 times 4 is 16, times 4 is 64, so this is negative 3 times 4 equals C. So C is equal to negative 12. So my equation would be negative 3 G minus 27 to the 1/3 equals T plus C. If they wanted me to get G by itself, I would just, C was negative 12, minus 12. I would start doing things like, first thing I would do would be to divide each side by negative 3. And then I put each side to the 3rd power. So G minus 27 would equal T minus 12 over negative 3 to the 3rd. And then I would add 27 to each side and get T minus 12 over negative 3 to the 3rd power plus 27. And then when they asked me to find G of, what is the temperature at time 3, I would take 3, put it into this equation, and G of 3 would end up being 54 degrees. If I have a calculator and I have this type of problem, I have just enough time to show this, so we're good to go. I'll turn off my camera for a second. I would go to my document. And if they gave me a differential equation, I'm just going to use differential equation solver. Menu, calculus, differential equation solver. The original one they gave me is listed right here, so it'd be G prime equals, I'll make a fraction. Oh, no, I don't need a fraction for that. They give me it, there it is, negative, parentheses, G minus 27, close parentheses, to the 2/3 power, comma, my independent variable is time, my dependent variable is G. I will hit enter, and that will have solved it out. Does it look different from what